Hello guys, welcome to JG Chemistry. Guys, today we are going to learn about name reaction, Robinson annihilation reaction, which is very important for the formation of six-membered cyclic ring. So let's see Robinson annihilation. So what are the requirements for Robinson annihilation? You should have a ketone plus one alpha beta unsaturated ketone in the presence of base. This is the prerequisite for Robinson annihilation reaction. If you have these three, you can form cyclohexenone, a cyclic six-membered ring having a double bond and a carbonyl bond. So we can say that a cyclic ketone is converted to another cyclic ketone with another one additional six-membered ring having a double bond. So that is called Robinson annihilation reaction. It is a combination of two reactions called Michael addition and aldol condensation reaction. Both reactions are very important reactions for any competitive exam, and Robinson annihilation reaction. So this is the cyclic ketone which you have in the presence of base. We know the role of base. It is going to abstract acidic proton, which is since both alpha protons are symmetrical here, same. So the base can abstract a proton from either side, and it is going to stabilize. The carbanion is going to stabilize through conjugation. So once the proton is abstracted from the alpha carbon, it is going to form the enolate ion due to the conjugation present here, and this enolate ion will react with the alpha beta unsaturated ketone, and this reaction is called the Michael reaction in the presence of base, obviously. So you can see here the reaction will take place through on the carbon. So basically it is a carbon-carbon bond forming reaction. So the lone pair of electron from the oxygen will go back, and the carbon, the alpha carbon, will attack on the alpha beta unsaturated carbonyl ketone. On 1,4 addition, it will show terminal carbon, followed by the conjugation will take place. You will get O minus. After protonation, you will get OH, and ketoenol tautomerism, you will get this product. So if you do the ketoenol tautomerism, you will get the product, which is CC bond forming reaction. Now again in the next step you have the next aldol condensation reaction followed by the dehydration. Aldol condensation reaction, we know it is the carbanion of one carbonyl will attack to the carbonyl of another compound to form the beta hydroxy carbonyl compound. Beta hydroxy carbonyl compound, after dehydration it will give you alpha beta unsaturated ketone here with additional one membered ring. So you can notice from the starting material in the product you have additional one ring with the one additional double bond. So this is called the Robinson annihilation reaction. So you should have a cyclic ketone, alpha beta unsaturated ketone in the presence of base. Michael reaction followed by aldol condensation. We'll see the mechanism. This is a ketone which is having alpha hydrogen in the presence of ethoxide base, will abstract the proton, forms the enolate ion. The enolate ion, the carbon is going to attack 1,4 addition on the alpha beta unsaturated ketone and gives you the product in the form of Michael addition product. Again you have the base, excess of base, which will abstract the proton, the terminal proton from here, the terminal carbonyl carbon. Then it is going to attack on the nucleophilic attack on the carbonyl, neighboring carbonyl carbon to form a six-membered ring which is more stable through intramolecular condensation reaction in the presence of ethanol. And so you have here beta hydroxy ketone, you have alpha hydrogen present here, so the dehydration will take place in the presence of ethanol and will give you the alpha beta unsaturated ketone. So this is the Robinson annihilation product, which is the combination of Michael and aldol reactions. We'll see a few example here. So let's say you have now the cyclic ketone which is having on one alpha carbon a methyl group. So this is basically a unsymmetrical ketone here. You have a base, sodium hydride, and you have alpha beta unsaturated compound. So basically you have all the requirements for Robinson ring and annulation reaction. So we know the role of base, it will abstract the proton. Now which proton it is going to abstract? The one which is going to form the more substituted double bond, the enolate. So more substituted double bond is going to form on the methyl side. So this proton is going to abstract and followed by the 1,4 addition, Michael addition reaction. You will get this product, which again in the presence of base the terminal proton is abstracted to form a product, and you will get here. So basically you will be having a carbonyl group here, which is not indicated here. So you write down a carbonyl group here. Terminal carbanion will attack on the carbonyl group, nucleophilic attack to form a 6-membered ring, followed by the dehydration method. You will get the additional double bond in the ring. Another reaction, you have a cyclic ketone, you have base, you have alpha beta unsaturated ketone. So you have all the requirements for the ring annulation. Your cyclic ketone is having an electron withdrawing group. Again the base will abstract the proton from the alpha carbon, which is going to form the more substituted C double bond C. So here the proton which is going to abstract from the COOET, again it is going to stabilize on the carbonyl, ester carbonyl through conjugation, and it will followed by the 1,4 addition to methyl vinyl ketone, and you will get the Michael addition product. Later on, again in the presence of excess of base, the terminal proton is abstracted, followed by the nucleophilic attack on the carbonyl carbon to form the 6-membered ring, followed by the dehydration will give you the Robinson ring annulation product. So you have additional ring here, carbonyl ring with a double bond. So 2 points we have to just make a point, that removal of a proton from the more substituted alpha carbon gives the enolate, which is more substituted C double bond C. Basically we call it thermodynamically stable enolate, which gives you the major product here. Another one is 1,4 addition takes place. Initially we feel 1,4, but finally the output sees that it is 1,2 addition to the alpha beta unsaturated ketone. So these are some points, and we'll see the last reaction for Robinson ring annulation. You have the enolate form of tetramethylsilane substituted enolate is given directly here. You have alpha beta unsaturated carbonic compound in the presence of Lewis acid. So now we know this tetramethylsilane is a better leaving group. So you will get again the CC form bonding reaction, followed by the 1,4 addition to the alpha beta unsaturated compound, and you are going to have the Michael addition product. Since you are going to form the CC bond here and it is substituted by methyl, so the stereochemistry will generate because of the chiral center. In the presence of base, it is the terminal proton which is going to abstract, followed by the nucleophilic attack on it, aldol condensation product, and you will get the 2 stereoisomers combination here. So this is how we can do the Robinson ring annulation reaction. The application is in the higher membered ring compound formation, like steroids, polycyclic compounds you can design. So it has a wide application. I hope you understood the mechanism and the reaction. Happy learning.